Let's go.
Right. Welcome, welcome, you guys. We're so excited. Look at this crowd. Oh my goodness. Who knew liquid immersion cooling was so exciting? So, well, I knew it, but anyway, we knew it, right? So we are here to look at this amazing lineup of 18 different fluids for immersion cooling. We're so thankful for all of the contributors. And if you're here, feel free to announce yourself, come up there and say, this is my fluid, and answer any hard questions maybe that get asked. We want you to have your questions too lined up. And anything you want to know, or you can come and scan the QR codes at the top and get a lot of vital information and let us know. So I'm going to pass it off to Rolf. Yep. But yeah, this is kind of Rich's baby. He's the one that kicked this off. So yeah. Oh, I'm Allison, by the way. Allison Boen. So.
Sure, yeah. So basically, it's also good to reiterate that there's a lot of people in the Immersion project that make this possible, right? So there is a lot of workstream leads. I think I got entrapped in sitting here and doing a presentation suddenly. I didn't even know that I was going to be talking now. But hey, yeah, this is also a Q&A to the entire team. So it's not just us going to be responding to the questions. So any of the workstream leads, would you mind standing up? All the Immersion workstream leads, can you all just stand up so people can see you? There's a couple. We're missing a few, quite a few actually. The whole list is over here on the screen. We've got a tremendous amount of work streams. Immersion, I mentioned it yesterday already during the keynote. The Immersion project is the biggest project in OCP. And it's not because Immersion is easy to do or because Immersion is now growing to the biggest market out there. No, it's because there is a lot that needs to be done, and it must be done. It needs to be done. The industry needs this technology to mature, and it's this tremendously active community that is making that happen. It's not a hypothetical whether immersion is going to be a big technology or not. No, it's a matter of when are we ready for it. And this readiness is something that all the participants in OCP are working towards, and it's not possible without the workstream leads. So all these workstreams that are on the screen, whether we're talking about material compatibility, fluid specifications, or requirements, or signal integrity, TCO, but I'm not going to name them all. These are all very essential parts of it. If you feel that there is a gap in what we're dealing with, and you feel that there is interest from a broader community or from the industry to participate in filling in some other gaps, we'd love to know about it. So this is not just a Q&A from you to us. Yeah, you can ask everything that we're always afraid to ask, but we would like to be able to ask you as well, what are the things that we're missing that we need to spend time on as a community, and that will help us kick off new work streams, new projects, new focus areas for a community to help transition this industry. Rich, you want to take this on?
Sure, yeah. Hi, Rich Lappenbusch. I'm working on the warranty immersion sub-work stream effort. And I just wanted to say that thank you for all the cooperation so far. I know that at least a dozen coolant manufacturers participated in the submissions, and I know that at least another dozen had products coming out at the show, or were announcing products at the show, that couldn't submit samples in advance. So I'll just answer this question right off the bat. We'll see you in Lisbon. We've already had enough demand for this particular session that people really want to talk about this. So Lisbon's our next stop for the Liquid Coolant Roadshow. And we're going to stop talking now and ask, there's mics on each side, so please line up and just, you can ask any question, no matter how rudimentary or how complex. We may not have the answer for it, but we'll definitely write it down. We've got you on video, and we'll come up with the answers after the fact if we can't answer them here. So please, let's have our first question.
And not all at the same time.
Everyone's shy.
Everyone's shy.
Really? Awesome.
Yep. Great.
The coolants are more than 98% biodegradable over 28 days.
Sorry, can you say that again?
How many of the coolants that are up there are more than 98% biodegradable over 28 days, which is the standard ATSM?
A few. More than a few. A few. A minority.
Maybe I can relay that question to one of the workstream leads for fluids and materials. Peter or Puneet, is one of you here?
I can answer that. So
Can you please do that? Can you please do it in the microphone so it's recorded? We need to hand out the microphone back and forth as well.
Yeah.
So one of the fluids up there is Nature Cool, made by Cargill, and that is a vegetable oil-based product. It's actually fully biodegradable in 10 days in the 301 test method. So, but yeah, that meets the criteria. So, but most of the you have to remember that the standard is actually to go to 60-degree biodegradable in 28 days to be considered fully bio. Yeah, 60% within you know, the 28-day period to meet the requirements for biodegradability.
Wow, thank you.
Well, thank you very much for helping out in that. Cosimo, I think
Since we're doing product, so Electricool, EC110 that's up there is biodegradable 98% in the standard 28-day cycle.
For that, we are trying to avoid product pitches and product positioning. So, yeah, go ahead, please, Cosimo.
What is the power density limitation that you see in immersion single phase?
I think that's a fantastic question. This is a recent topic, by the way, that we've kicked off in the immersion community as well. There's been a lot of talk about the ceiling of immersion cooling when it comes to thermal capabilities. That's what you're referring to, right, Cosimo? Yeah. We published an article about it recently as well on LinkedIn, and this is a very interesting discussion, because if you look at immersion technology right now and the state of immersion technology, basically what we're doing with this technology family is we're just moving some fluid around in a big tub, and we're hoping that it's going to cool all the components, right? With the path that a fluid will take is the path of least resistance. The heat sinks are often more resistive to movement than the environment around it. So in the current applications, most of that fluid isn't even going through heat sinks, but it's still doing the job. Is this implementation type really the measure that you want to take to extrapolate what the capabilities are of immersion across the board, across the future? I would argue that although immersion itself is an innovation, immersion has not innovated yet. It's still at the basic starting point of an innovation curve, because it's not doing anything intelligent yet. It may seem odd for me to say it that way, but it really is what it comes down to. So this is why we're now focusing, because this is a discussion, and yeah, I understand where the discussion is coming from, and we're going to need some more insight on where it's going to take us, because hey, it's definitely going to take us a lot further than just next year. How much further? That's a great question. It's something that only the R&D departments of the various companies can answer. So we've kicked off a series that was introduced last month in the community call by Kelly Mullock on the topic of precision cooling. Kelly has presented one company's view on what precision cooling could be. Upcoming month, we've got GSE coming in. That's a Kelly Mullock is from Isotope. Next month, we'll have GSE giving them some insights in how they are perceiving precision cooling and over the years and what that future might look like. I noticed yesterday as well a very interesting display on the Intel booth. That was a collaboration with Submer, where they demonstrated just how much difference it is if you just apply some mechanical directionality to the cooling and make sure that you force the fluid through a heat sink, how much difference that makes. And they're just showing it in that little. I can recommend everybody to just have a quick look at it. It's just a demonstration of the principle. Just ensure directing that flow. doing that chip is doing 800 or 900 watts, I think, without any problem whatsoever. So I would argue that I cannot give you a direct response with a kilowatt figure. All I can say, hey, look at what air has done over the years. Whatever air can do, liquid can do always a lot better. That's just science behind it. And liquid hasn't started doing anything smart yet. So I'm really looking forward to the innovation cycle. Does that long answer your question? Okay.
And when you talk about density, I'll suggest one idea for a metric, which is kilowatt per liter, not necessarily rack or rack unit. So think about density in a different way, and it suddenly becomes interesting. So potentially about, 1/3 of a kilowatt per liter. Something like that is a place to start.
David, you're good. I was just going to say, make sure you go look at that Intel booth display, because if you don't really understand what you're looking at when you're looking at it, but then once you do, you're like, oh, wow. So very impressive. I just want you to know, I was blown away. So, David, I can tell it's you, but I'm blinded still.
Two questions. First question is, from point of view of performance, efficiency, is biodegradable fluids have advantage in comparison with not biodegradable fluids? And second question is, can we make back to the environment biodegradable fluids, or we should proceed in the same way as not biodegradable fluids, I mean, in the end of life?
Do you want to allow some of the fluid providers to come out and answer?
Yeah.
If you are a fluid provider and you would like to get up there and help answer some of those questions, we would love for you to take the mic.
Okay, so there's been not a lot of in-depth studies in all the different fluids. So when it comes to end of life of a fluid, if you have a petroleum-based fluid, there's purification methods that will be able to regenerate it for use. And if you're going to have small losses every time you purify a fluid, but you can a hydrocarbon-based fluid can probably be reprocessed, about 40, 50 times before your losses of purification get so small that you're doing significant replenishing. And if the fluid lasts 10 or 20 years, that's hundreds of years that you can use those fluids and keep regenerating before, they have to be repurified in a more energy-intensive way. And even, ester fluids, natural esters, those can also be regenerated. In our own labs, we've been doing extensive testing on what it takes to regenerate fluids. So that makes it a circular way to continue to use those materials and prevent them from having to be disposed. And then you have, secondary uses that the fluids can go into. Many of them, isoparaffinics are biodegradable in the environment. Some of the isoparaffinic species take a little longer, but and then the esters are very much biodegradable because they, have that carboxyl and glyceride function on there to get the bacteria started chewing up the chain. So, they're, as far as the life of the fluid and environmental impact, I can't speak for every fluid out there because I don't know the composition of every fluid, but most of them aren't going to be really dangerous to the environment.
Thank you so much. Oh, do you want to help answer that too, real fast? And then John, we'll get to you next, right now.
Hi, I'm with Eneos. We also have a plant-based fluid up there. And my background is actually in used motor oil re-refining. I would definitely speak directly with any fluid provider you're interested with to see their recommendations, but I would expect almost every hydrocarbon-based immersion fluid to be very happily recycled in a standard lubricant used motor oil refinery. That carbon has a lot of value. Are you asking, should you pour your biodegradable fluid down the drain? No. Don't.
I would like to also add to that, and this is something that David is running the immersion hurdles or immersion challenges. That's what we call it these days. He's running that work stream. Immersion fluid lifecycle management is a recurring topic in there, and it is going to get some more attention. There's already some talks within the challenges group to start formulating the collateral that we need to kick off new work streams around this topic as well. So it is something that will get some more attention in the upcoming year, I expect. I've seen a lot of attention in the working calls, right? Is there anything you want to add to that, David, Raul?
Next month, we will announce that.
All right, next month you're going to have a top. Okay, great. I'll add it to it. So, yeah. Dr. John Summers, it's always a pleasure to have you there, and I'm always terrified for what kind of question you're going to ask.
Oh, no.
I'll wait for this one then, yeah. No, I think as a scientist, we always look at the properties of the fluid. So just go back to the beginning and say, well, what for the technologies that we're using, what are the properties that you really want from the fluid? So I mean, for example, surface tension, density, thermal expansivity, dielectric strength. What is your ideal that you want for this for immersion? And can we get there? Because we're always trying to bend the laws of physics, aren't we? Whatever we do, but we're always faced against physical laws. So I don't know whether that's a fair question, but something that I thought would add a bit of spice to the debate here. Yeah.
I really like that question because it also connects very well with the keynote I did yesterday, right? On how there's no one answer to any question. Basically, that's the actual keynote was how there's no one solution that fits all, but it fits here as well, right? There's no one answer to a question like that. Because it depends on what you're trying to achieve, whether it depends on what you're trying to achieve with an application or certain performance criteria. Yes, for super high performance, for super effective flow rates, viscosity obviously is one of the main dials that you want to turn. But when it comes to heat reuse, there might be other dials. When it comes to certain other efficiencies or material compatibility, there's other dials that you can turn. And very often it's the case, especially with these fluids, when you turn one of the dials, 20 other dials start turning in random other directions as well. That's part of the complications, right? That's the challenge. So overall, I think the fluid specification that was published last year, that was generated by Intel, so that's a fantastic baseline. It lines out figures of merit. It lines out various other properties that are considered to be very important for these fluids. And the sustainability angle, like global warming potential and biodegradability, are in very important parts of that as well. I don't know if there's anybody here who would like to elaborate on what they think would be important factors for a fluid, so please feel free to take a microphone and respond to it before we get to the next question. Is there one of you that was near the microphone who wanted to respond to that? Yeah.
Yeah.
Hi, Puneet.
Yeah, hi.
Please introduce yourself as well, because I don't know if people have seen that you're one of the workstream leads here as well, right?
Myself, Puneet, and also here, Peter Cooper. So we run the fluids and materials workstream here. So to answer your question, John, I would suggest you to look for the OCP baseline fluid specification. I think that gives you a good starting point. There are so many properties you need to measure for fluids, but I would start there first, and then you'll get to know what are the properties like thermal conductivity, density values, and then viscosities. All the properties that you look for, pore points, that is really required considering the scenarios where the fluids will be exposed to. All the things are captured in that.
Okay, please introduce yourself, and it's difficult for me to see who you are, so there's a spotlight right behind you. So.
Yeah.
Okay. Hi, this is Raj from Micron Technology.
Hi, Raj.
Hey. Yeah, question about if the panel members or community has thought about accelerated testing in the liquid, immersion cooling environment. For example, for air cooling, we have highly accelerated stress tests with high humidity and temperature, right, for component lifetime reliability testing. Are there equivalents for immersion, or have we given it any thought?
Yes, and I would love to hand this over to the two people that Puneet just met, Puneet and Peter. Can one of you guys comment on this on behalf of the community here? This is your expertise.
Thanks. Yeah, two things there. So there's acceleration of the fluid aging, right? So we've got a focus group now in the materials and fluids work stream focused on coming up with a common test method for that accelerated aging. And then there's also the material side of things, right? So accelerating the aging of materials or components. And that's kind of covered by a couple of different work streams. We've already got a test methodology that was published last year and presented last year. And then we're working on a revision of that right now as well. So at the moment, there's a proposal on the material side to do a 2-week accelerated aging test, 80 degrees C. And yeah,
Cooking the boys.
that's for the component, and then for the fluid, we're still determining the best test method, but there are a couple of IEC and ASTM standards that look like they're fairly relevant to us.
Yeah.
Thank you.
Yeah, thank you. Some of the methods that you mentioned, I did see them in the work stream. That's great. A lot of them rely on thermochemical interactions, and the electrical testing is not possible after those tests, right? It'll be good to think about that.
Yeah, that's part of the challenge we're trying to tackle now. Is like up until now, the test is more focused on aging the fluid and aging the material, and then doing kind of the basics set of fluid and material tests, right? The next step is now, okay, how do we actually check functionality, right? So it's not just, it looks okay, right? It's actually, does it still work? And can we do the full range of tests on the component side to make sure that that works?
Okay, thank you.
Thanks.
Anyone else want to follow up with that question, or is that response? Okay. Yeah, go on.
Perfect segue for what I was going to ask. So I'm Dennis Breen with Molex. So the EIA standards, right, for our connectors and all of our devices, for example, they're designed around air failure modes. So we're going to be looking towards how do we define a set of test standards that go towards the failure modes of those components that happen in fluids, right? And those are different, and they're going to look different, and I think we need to revamp how we think about those EIA standards for this application in fluid. So that's the segue into my question, actually, which was a perfect segue, so thank you for that. We're looking at 18 fluids up there. Each one of those fluids have slightly different electrical properties, like decay values, and those values change how our connectors perform in the fluids. For example, if you have a creepage and clearance distance on a high power connector, or if you have signal integrity performance on a high-speed data connector, each of those fluids will cause our connectors to perform differently. So what we're looking for is an understanding of how do we get to some commonality on those electrical parameters, similar to what air is, for example, so that we can develop a connector that will work in all the fluids and not be in a position where we would have to decide what fluids we're going to develop a connector for. So that's the question. How do we get to that level of commonality on some of those parameters?
I think that is an absolutely fantastic question, because this is really what drives this community as well, these kind of questions that really helps focus the communities. And again, Peter Puneet, you might as well stay at the microphone over there, right? This is what you guys are working at with the Fluids and Materials Group, right? So you care to respond to it, Puneet? Excuse me, yeah.
So we are doing actually work involving all the experts in the market, 7 different work stream subgroup efforts happening in fluids and materials. I think on the fluid side, as Peter said, more focus has been given is what happens to the fluid when it is immersed and when it is reaching a point 5 years, 6 years down the line, how the fluid is behaving. So we are actually trying to understand that with respect to performance and as well as on oxidation. And then how these fluids interact, because there are so many different chemistries available, how are they interacting with the components? And I think adaptation of what we published last year in the white paper about what methodology we need to use to do individual component level testing, which involves various key materials like thermal interface materials, plastics, rubber related materials. How do they interact with these chemistries? I think that is getting adopted now. I think people are getting to know what methodology we need to use to understand with different chemistries how these components behave. That is one aspect. This year, I think more on handling of fluids, and then if you are swapping different chemistry fluids in hardware, how do we clean them? What type of cleaning procedures we need to follow? That is one aspect we are covering. The other thing is, obviously, we did start with component level testing. Now this year, we are trying to focus on what are the key, most important component that we need to be addressing, plus server level testing and also tank level testing as well. So there is another work stream which involves manufacturers who are actually designing tanks and fluid manufacturers coming from both single and two-phase fluids. So that, if you are designing a tank with two-phase fluid, involving two-phase fluids, how do we engineer these tanks? And then what are the precautions and how do we handle these fluids? That aspect is also taken care. I think that's probably it. I think this is coming, all these initiatives are coming from the experts here. It's because there are a lot of things which were missing when we started this year. We identified these key 7 topics we need to work on, and we are actually delegating a lot of leads sitting here in this room. They're driving this to come up with these white papers so that the intention is next year that maybe there are 3 or 4 different white papers we publish so that people will start adopting it. And then give us the feedback. If there is any modifications required, we are always here to revise. That's the plan.
Thanks, Peter. And there's also another work stream that requires mentioning here. It's the power delivery and immersion. It's run by Oriol Chevenel and Kevin Giro from respectively Submer and Murata. Is any Oriol or Kevin? Is any one of you in the room? I guess not. All right. That's a shame because that. But you're already working with that team as well, right? So, yeah. But it's really good. I understand that this may not have been the explicit answer you were looking for.
Of course, right?
But yeah,
Intel spec is awesome, and how do we get to commonization of some of those electrical properties? I think that's going to be key in order for mainstream adoption of components. Thank you.
So yeah, it's work in progress. This is exactly one of these topics that is work in progress that we need to get a grip on before immersion can properly scale in the industry, right? So yeah, thanks for that as well.
Rolf, I just want to respond back on the aging testing. I think that's probably one of the most important things that hasn't been accomplished yet. We just finished a 10-year accelerated aging test that we'll be publishing a white paper on with full results from APL Landau out of Germany. And I can tell you from having gone through the process, actually coming up with the method of getting that to be done was a lot more difficult than we originally thought. A lot of the work that your teams have done have been really critical to what we tried to implement in when we did that test. So when we publish those results, it'll be interesting to see where we can go from that. But I still think that long-term stability is probably one of the most challenging areas that we have.
So I would love to invite you to work together with the community as well, right? So we've heard from you also for many years by now, but it's fantastic that you're doing that work. It would be also fantastic to be able to do that work in collaboration with the rest of the industry, so we can actually share and peer review the outcomes and allow the industry to move further with that. So maybe with that, it would be great to get some insights from you on that subject material, on that paper that you're publishing, or maybe consider publishing it through OCP and harmonizing it with the rest of the fluids community. Consider it an open invitation, Gary.
Hey, Rolf. Just an answer to the question about the signal integrity and the connectors. I think currently the fluid spec gives a limiting value for the dielectric properties of the fluid, but I think what that means therefore is the parameters of the fluid from a dielectric perspective could be at a value or higher than a value or lower than a value, which is going to lead to a challenge in design and component selection to retune the impedance changes caused by immersion. I think what may happen, I mean, we have to decide as a community, but where we can define a range rather than a limiting value will enable you to design your component selection processes so that it can work across the range of fluids if they have properties within that set range. So what that range is, well, we need to determine that as a group, but I think that's one way in which we can help the OEMs and the ODMs to specify equipment that will work with any of the fluids on that list without causing degradation to performance in signal integrity terms. I think Kai has a point as well to make on this topic before we move on.
And I will help the signal integrity sub-work stream, help the community. So answer the previous Molex and Micron's question. So Molex is about the interconnect is important in the immersion. So I'm glad to see the interconnect company to help because expose the conductor matters. The dielectric of all those oil around 2 dielectric constant, Epsilon R around 2 to 2.0 has an impact on signal integrity. But if we can change the impedance of the connector for the future powerful signal, it will help. So I think the dielectric range we are given. Regarding to the Micron's question, I think the fully functional signal integrity test is consistently being done around the world in the large-scale data center. People do collect the margins, do find the long-term the signal quality of those servers. We already published some data in the workstream. We will continue to publish the data. Thanks for all those large-scale cloud immersion customer contributed to the OCP. So far, we are very optimistic. We did not see the long-term degradation from the functional. We are happy with the data, long-term data so far.
Yeah, and thank you both for your work in leading that work stream and pulling all the cats together and trying to herd this. I'll add in some business factors that may not be so obvious to all of you, but I do want to throw in. I'm the guy who had to drive from Seattle for these because there was no way to get on a plane with these. So there are real world factors that are impacting our ability to deploy this stuff. So I would ask you to think about this. You need to think about your personal protection equipment, and you need to think about your material safety data sheets. And, you know, as an ops guy, those go everywhere with these coolants, from life to death. That's just kind of in me as an ops professional. And I'd ask you to think about your ops peers who are actually going to have to run this stuff over 10, 20, 30 years. So those are important factors. I'll also add as a shameless plug for the warranty side, a lot of the auditors are getting involved, and they don't necessarily care so much about the vendor-specific data sheet. They want to hear from the industry at a peer-reviewed level before an auditor is willing to say, okay, that's ready to come into my facility, or that's ready to come into my environment. And I know how to dispose of it, I know how to clean it up, I know how to deal with it if there's a spill. These are important factors from in the States called OSHA, but functional equivalents all worldwide. So some business factors to consider. Thank you.
Thank you. May I ask about the accelerated testing for two-phase immersion, because the boiling point is fixed, and then do we increase the pressure to go higher boiling point, or we use some similar chemicals with higher normal boiling point? So for two-phase immersion accelerating.
I'm really certain that the three of us will have to defer that. Any two-phase people in here or with the ability to respond to this?
Sure, Rolf. Gustavo from Chemours. So we actually do something very similar that people do in refrigeration at ASHRAE. We cook the fluid in a glass tube, in a seal tube, at up to 150 C or 175 depending. And then we cook that for about 1 week and we do chemical analysis on the fluid.
Yeah, thank you, Gustavo. But I'm talking about like system level. We have the immersion and the baseboard and all the components. So like if we put it in a tank, seal it, increase the pressure, or we test it with a similar fluid with high pressure.
We test components, so we are going. The OCP has some recommended guidelines for testing materials in by SOx extraction. But the tests are done usually during 48 hours at atmospheric pressure at 50 degrees C.
Okay, thanks.
So, just from my understanding, is this something that we? Because I can also understand, hey, if this is not a satisfactory answer, it might be something that we need to take into the community to formulate something around. Is that the case?
Yeah, I think I'm more thinking about like product life. Like we qualify air products. We tested like mentioned before, 85 for a certain time for that. But for the baseboard or chassis, the whole server unit, when we qualify for the immersion, we can only test at that boiling point, right? Unless we increase the pressure or use a different chemical. So we are not accelerating anything in that like system level testing, not component level testing. So that's the challenge, I think, for two-phase immersion for that acceleration or the aging test.
All right, fantastic. I'm sure that Peter and Puneet are going to be taking note of that for follow-up.
Excellent question. We don't have an answer because I think two-phase is there in the industry for a long time. Your question is like if it is deployed for many years, what is the level of performance of fluids with respect to oxidation? I think please join the workforce that we are involved. I think the representation has been mainly coming from the single-phase manufacturers, but here is the opportunity. I keep asking in every call. We need more representation coming from two-phase fluid manufacturers because they will know much more about the science behind how do we evaluate long-term.
And end users.
Yeah, end users as well. Yeah, please.
Thank you. So consider it an open invitation to you as well. We need you.
Along the same lines, by going back to single phase, single-phase immersion has been around for quite some time now. So what are the experiences based on 10 plus years of use of single-phase immersion in terms of durability and breaking down the fluids, et cetera, et cetera?
Field data and generic, yeah. I'll speak on behalf of personal experience of Supermicro and the aggregate. We have had testing going on with single-phase immersion for over 11 years with various vendors, and we've seen a wide variety of results and it's everything that's already been uncovered in the working groups. But what surprises me is the amount of durability, how durable. Once you get past the cables and the connectors and some things that are obvious we got to fix or redesign or retest for, I think it's amazing how durable the tanks are and some of the coolants and some of the core systems, the core infrastructure. Much more so. I did not think that some of the tanks we got 11 years ago would still be operating at Supermicro, and they are. And we've totally abused them. Tried different coolants, emptied them, refilled them, done a lot of different things with them. So I'd say that it's surprising how durable this stuff is. Average. Now, of course, that doesn't help anyone because you're trying to do a specific deployment, trying to accomplish something specific. But I think we have a better head start than we might think we have.
Can I say something? Yeah. I will tell you that, there's case studies out there, and I was just thrilled to be able to tour CGG a few months ago, and they're like a museum for immersion cooling technology. It's been deployed over 10 years. They have several generations and several different fluids. And I will say the only thing I can tell you is each tank is a different color, but it's all just a little. But they, it was just really cool being around the I say younger man, he was, in his 30s, that was running the facility. And he was just matter of fact, we test our fluids every month. We send it off, independent testing to make sure everything is good. Everything's cool. We're good. Just a real easy peasy. It was just spotless clean in there. Honestly, it was so impressive. So there are a lot of case studies that are out there of fluids that have been running over 10 years. And it just, they just keep going. And that's what the whole argument behind immersion cooling is, the fact that some of those systems have been in there 7, 8 years running in that fluid and with no problems. So they are out there. We just have to look for them. So.
And one more thing, from a logical perspective on how these systems actually function, the inherent stability, the thermal stability is greatly improved compared to air cooling, the lack of hotspots, the fact that it's constantly immersed in the fluid, which keeps the equipment clean as well. These things really contribute to the principle. The biggest challenge is actually in the deployment, to get things up and running. If it's running for 2 months straight, it will run for 10 years, right? That's pretty much a rule of thumb, right? The real challenge is getting that first 2 months stable, and because there's always some new stuff, something that wasn't anticipated, or something that hasn't been done in immersion yet. It comes with the field at this stage of the market. But when it's running, it's typically just, hey, it requires the least maintenance of the entire facility suddenly, right? What it typically comes down to. Yes, please.
I'm Brian Kincaid from Fuchs Lubricants, and I'm just going to call in the acronym police. What is CCG, Allison?
Oh, gosh, I don't know what it stands for. Ken, do you know what it stands for? I know Ken's out here.
It's a company name.
Oh, it's just a company name. Sorry,
Okay.
CGG. Maybe that's it. I don't know if it.
ChatGPT.
Yeah, all I know is that they plot. It's a supercomputer that plots the ocean floor. Honestly, I don't know. It's like super intense, like way beyond all of us. So.
Okay.
Yeah. Very cool. Yeah.
All right. Perfect. Well,
Was that
I'm
your
in
question?
oil and gas, and I don't even know that.
Was that your question? That was your actual question? So, I'm going to call out.
No, I just like being the acronym police.
Oh, okay. I love that. I'm going to call someone out. She is going to hate me when I do this, too. Gemma. I know. You knew it. So I would love for you to talk about what you and your team in regards to testing, because you're testing the fluid for a different reason, for more a facility side reason. But can you just speak a little bit about that? I'm going to call her out.
Thanks for that, Allison.
You're welcome.
Yeah, I suppose we're looking at it from a different point of view. So I'm from Alpha Laval, so we work with the heat transfer side of the fluid and the movement of the fluid. So I'm also really interested in everything that's been talked about today. I think it's a really interesting field at the moment. But where we're interested in how easy it is to move the heat, to remove the heat from the systems and from the baths. So we are looking at, we've talked about the different properties that different people look for. From a heat transfer point of view, being extremely selfish, we want viscosity to be low. We want to be able to move it through the equipment easily. We want thermal conductivity to be good so we can take out that heat. But as a lot of people have mentioned, that does come with other issues. It is always going to be a balancing act between what I would like as a heat exchanger manufacturer versus what we need in terms of the properties of the fluid for the conductivity and things like that. We are doing some testing on different things. Material testing from a heat transfer point of view, they're predominantly using copper brazed heat exchangers, which will be stainless steel and copper. But there are lots of other different possibilities when you get onto larger size systems that might want to involve gasket materials, for example. So rubbers, elastomers that are used within the heat exchanger. And we're doing some testing around that at the moment to see, does it have to be a Viton-based gasket? Can we look at more commonly available gaskets such as nitriles and things like that to see how they react in terms of swelling and degradation and things like that to make it more viable and more of an option to make it more readily available into the market at the moment.
See, I knew you could nail it. I love that. Thank you. So, yeah, wonderful.
With no warning. Thank you.
I know. You're welcome. Sir John Summers again.
Hello, yes, so it's John Summers from RISE, Research Institute of Sweden. So up in the ICE data center in the north of Sweden, we've done quite a bit of testing on performance of IT systems at various different temperatures. And one of the things that we found, in running 500 kilowatts in a cold climate, just using air, is that if you slow down the fans and you run everything hotter, you draw more power in your electronics because of the current leakages. The opposite end of that is what happens if you go colder and if you drop the temperature lower, which we've done in immersion systems, but how low can you go? The problem with air is you've got dew point control, which you don't actually have a problem in immersion. So one of the things, I want to turn it on its head a little bit here, because what's coming down the line is the topic of cold CMOS. And I don't know whether people have talked about this much, but cold CMOS is about running at much lower temperatures. The problems of heat recovery, if you want to call it heat, if we've got to use the heat, the heat's not going to be there so much, is it? But anyway, I just wonder what you thought about that as a prospect.
I think it's... You always come with thought-provoking ideas. I didn't expect this one from you. But I would argue that there is a dew point problem also with immersion, because that fluid needs to be cooled down to whatever temperature you need. That's still done with either water or you're going to have to extend your entire facility infrastructure to contain these dielectric fluids. I don't see that as an absolute blockage, as something that is impossible to do. I also don't think that is a likely scenario for a facility to be fully dielectric based. I know from experience, but also from what I see, and it's for good reasons that across the cooling environments, we typically recommend dew points as an absolute minimum temperature for any liquid cooling technology. Why? Because there's always an interface to the water system, and you're gonna need to get below that dew point to deliver that temperature to ensure that you can achieve those temperatures. And that means you're gonna have this crazy potential for condensation in areas that is where the pipe work is going to interface with immersion fluids, especially with open baths. There's quite a few challenges that we prefer to stay away from at this point in time. Whether there might be other ways to achieve that, yeah, of course, anything is possible. But right now, with the current state of technology, again, please don't extrapolate that to tomorrow, right? Our current state of technology. Overall, broad recommendation within cooling environments is dew point is the absolute minimum that we're focusing on. Does that resonate, John?
Yeah, it does, yeah. But why not go cold? I mean, you can seal the system. Why not go colder? I mean, you don't...
Well, can I follow up on this? Because you do have the air fluid interface, and you can seal it, but you still have maintenance activities.
Okay.
And you would then have to warm the fluid to get it up above dew point, to make sure that when you open up the lid, you don't get condensation within the fluid settling to the bottom. So we typically recommend keep the fluid slightly above dew point, that you're not exposing it to possible condensation.
Okay.
But that doesn't mean it's not solvable, though.
No, okay, yeah. Okay, thanks. Yeah.
So it basically just means that if that's a road that you're going to go through, it's likely going to be a specific solution for a specific application, right? And then that would probably makes sense, but yeah, please go ahead.
Along the lines of fluid properties, we talked about dielectric properties and electrical properties. What about optical properties and the effect of fluids on optical connections?
Mm-hmm. Very nice one. Yeah, this has been a discussion in the community as well for a long time. Because there are challenges with optical connection. To just summarize for the people who are not familiar with it, we all know optical cabling, optical interfaces. If you plug an optical cable within an immersion environment, there might be a layer of fluid sitting between the transceiver and the connector, which might distort the light signal. On the other hand, there might also be chemical reactions with the material that the optical cable is made out of that can affect, also interrupt the light signal. So at this point in time, the only solutions to that have been the DAC cables, the with the integrated QSFPs, right? Direct attached. And there's been at least one supplier, so we're not going to frame the company name, but there's at least one company in the immersion community, and I know there's a couple more that are not in the immersion community, but that they're doing something similar, that have developed the fully sealed connectors for this kind of application, especially for the external network connections. But you are talking about SFPs, QSFPs that are fully sealed. Yeah. When it comes to onboard equipment, other types of solutions are going to be needed, because even if you want to use an optical cable to connect two devices within the system, yeah, obviously that's going to be that will have to be engineered in a different way, because in immersion that's just going to be, because of the different medium and the varying. Even if you look at this, even the coloration of the different ones, yeah, there's no way to say, well, okay, this one will fit with. You can maybe engineer one that works with one particular fluid, but it won't work with the next. So that's, yeah.
Yeah, so in the server environment, you have a very limited number of interconnects. When a networking environment, my devices have like 250 hundreds of optical connections. So that's a very different environment. I'm not looking at solving it for, one or two optical ports in the front of a server.
Yeah, so, hey, and this really, mind if I tie this back again to the keynote that I did yesterday? Because this is really, that's one of these elements that go into a decision process on, hey, which technology am I going to use, right? If you have a platform that is incredibly heavy on optical connections and it literally disqualifies the use of these kind of optical cables, or even the immersion optimized ones, for whatever reason you have, right? There are other liquid cooling solutions out there, and it's not like immersion is never going to address everything in the market. And I want to make sure that I emphasize this. Immersion is one of the technologies that is essential in an ecosystem of cooling technologies that we need to support a highly diversified server landscape. So 10 years ago, the whole server landscape was pretty homogeneous with similar types of systems for all the applications. Right now, that is no longer the case. You got a 20 kilowatt GPU system alongside a 500 watt general workload system or a cloud optimized system, and you've got a specialized or another general workload system which contains 10 network connections versus a cloud system that only uses one. So you've got all this incredible variation in the market. You shouldn't be looking at your entire ecosystem and say, okay, I'm going to get immersion for everything. No, hey, what you're explaining is a really good example of, hey, if you've got part of your platform that is really dependent on that high connectivity, the high quantity of interfaces, you know what, maybe it's a great idea to put it in a radar-cooled rack and employ some cold plates and focus your network equipment on that side and get your more general workload systems that don't require that level of connectivity or maintenance or continuous access, deploy those in immersion, for example. And that's a really reasonable approach. Some things are just different. Some things may just not work out that well with immersion compared to something else. Other things will. Does that help? Yeah. All right, thank you. And I hope I didn't offend anyone with my statements just now about immersion not being able to do everything.
Hi, Ken Copeland with Green Revolution Cooling. You'll notice we have 5 different fluids that are listed, but we are not the manufacturer of the fluids. The ones listed from Japan are from our partners at INEOS. INEOS is here in attendance. If you would like to talk to them about any of the fluids up there, they would be more than happy to do so.
Okay, but we prefer not to do commercial plugs on the fluids.
We don't manufacture these. We have, the other manufacturers' names are up there, but these guys aren't called out. So I just wanted to make sure people know who to talk to.
Good to know.
So we're at 3 minutes, so we should do wrap-up comments. So I just want to wrap up real quick and say thank you for coming. Thank you for participating. And have you think about one thing. Of all these questions of incredible depth, this group collectively almost answered all of them. So think about that. The power is in the community and the cooperation.
Absolutely. Please go on.
I think if you did submit a fluid and you want to come up here just for the last couple of minutes, if anybody wants to ask you any questions, we'd love to give you the opportunity because that's what it's all about. But also, if you are not involved in OCP and you are here and you're obviously here, but believe it or not, there are people here that are not involved in OCP. So we just want to encourage you to get more involved in some of the work streams. If you're not, if there's something that piques your interest, you just might be surprised. It's like the hurdles to me is like was one of the most important. It was actually the first one I really was like, oh, I'm so excited about this one. And out of the hurdles was born the TCO and the warranty and the signal integrity. So, it just keeps evolving. And okay. Thank you guys again. Anybody else have any last minute words they want to say or? Okay.
Well, we're all going to be around the event, so make sure to look around for some of the workstream leads. Anybody who's working with Immersion, go ahead and ask the questions. Tomorrow is going to be the day that everything is going to be about Immersion in at least one of the rooms. I forgot the room number that we're going to be in. Does anybody?
It's upstairs. Yeah. Oh, and can I say something? It's a deep dive tomorrow. A deep dive into Immersion.
Yeah. So all the leadership is going to be there. We're all there in the room. We're managing all the sessions. We're supporting all the sessions. All the community work is going to be presented on maybe not the very, very latest, because some of the materials we haven't been able to get on the roster because they really got kicked off properly in the last 2 months. But so a lot of preparation that goes into it. And I just want to do a shout out to all the volunteers, because this is such an intense amount of work and everybody is a volunteer doing this, right? So this is not something, I'm not getting paid by OCP for doing this, neither is anybody else. They're always representing our companies, donated time, and the corporate hats are always left behind at the door. And it's astonishing to see how much work is getting done. And it's all the workstream leads that are doing this. So shout out to them, please. You know what? Give them applause for anything, right?